Hey, welcome to Unit 12. Unit 12 is the study of statistics in Algebra 2. It's a short unit. There's really only a few things we really need to know here, but it's not an easy unit. That's why I usually save it for last. So you guys know what statistics is. I mean, you see it, you live it, you see it and you're on your phones. Oh, statistics say that, 4 out of 5 people surveyed enjoy, eating, chewing Trident gum or something like that. So, and that's based on a bigger sample, or sometimes things are considered um, on a full population. So that's the first thing we're going to talk about is the difference between the population and a sample. If you're given a sample of something, it's like, in other words, if we're considering the opinion of school lunches here at Poughkeepsie High School. And we ask people, let's say in the first lunch period, and we don't consider anybody else, then we're only picking a sample of that population. Making sure that sample is fair is very important too, and we'll talk about that a little bit later. The second thing is if you wanted to get a survey of the entire population, you would hit every lunch period. Plus, you would make sure you're giving a voice to those people who aren't in the lunchroom because maybe they don't like the school lunch here at the high school. Now, Chef Dave wouldn't be happy if I was talking about this, so let's not make any inferences about the school lunch here. I'm just using it as an example. So distributions. So data sets are described using the shape, center, and spread of a distribution. The mean or the average, the statistical average, that's the average that most of us use to find the average, is also the median and the mode, which are also um, centers of normal distribution. All right, is used to describe the center of distribution. So the standard deviation is usually used to describe the spread of the distribution. A distribution is skewed or symmetrical. If a data is skewed, it is skewed in the direction of the tail. If a data set is symmetrical, it is sometimes also considered bell-shaped or normal. So you've heard of a bell curve or a normal curve. Hopefully in Algebra 1, you remember some of that. So here in exercise 1, describe the shapes of the following distributions. Hint, are they symmetrical or skewed? If they are skewed, what direction are they skewed in? So I'm hoping in letter A here, you see that this is not a normal distribution. This has a tail. All right, so what happens is this one is said to skew left because it skews in the direction of the tail. This is a beautiful representation of a normal bell curve, or we'll say this is symmetrical. And this one, even though it's not a normal curve, it is most definitely symmetrical, right? So because this one looks like, so if you look at it, it is symmetrical. Not considered a normal curve, but that's okay. We're just talking about whether something is skewed or symmetrical right now. In exercise 2, the shape of the distribution below can be described as most definitely not symmetric. This one would be skewed to the right because that's the direction of our tail. So skewed to the right. All right. Uniform, not necessarily. We haven't even talked about what uniform is. All right, so the normal curve and z-scores, I'm sorry. Normal curves and z-scores. If a data set is normally distributed, now this is kind of important for z-scores, normally distributed, the mean falls in the middle of the bell curve. So the empirical rule says that approximately 68% of the data lies within one standard deviation of the mean, and approximately 95% of the data lies between two standard deviations of the mean. And this is the most important thing we have to talk about, and that's what we're going to be doing. Oops, sorry for the interruption. Okay, so I don't even know what I was saying. We were talking about the approximately 95% of the data lies within two standard deviations of the mean. So what I'm talking about is if you consider that mean, that perfect bell curve here, and you consider this being the mean here. Now, one standard deviation goes in each direction, and two standard deviations go here. So we're saying between two standard deviations from our mean, we should have 95% of the data. All right, now there's something called a z-score, and that's the measurement of data values distant from the mean compared to the standard deviation, which is the average distance from the mean. The formula for the z-score is this, and this is unfortunately something you have to know. And I'll tell you that the beautiful thing about this is that if you use it for a while, it becomes kind of innate and kind of stuck in your head. So the value that you're given minus the mean divided by the standard deviation. So if it's negative, it means it's below the mean. So it's lower than the mean. And if it's positive, it's above the mean. So if you're thinking about something like test scores and the value you have turns out to be negative, you know you're falling in the lower half of the data. And if it's positive, you're falling in the upper half of the data. All right? So, and if you're asked to calculate a probability, right here it says to calculate a probability, you're going to use normal CDF on your calculator. Now, don't say this because this is part of a TI-84 thing. I will show you how to do this on your TI Nspire, and it's not hard. And you can usually tell when you have to do a norm CDF when you're given a spread. So we'll look at a couple of those examples in exercises to come. So exercise 3. The weight of adult male grizzly bears living, having a tough time reading today, I'm sorry. The weight of adult male grizzly bears living in the wild in the continental United States is approximately normally distributed with a mean of 500 pounds. So this is important, normally distributed, mean of 500 pounds, mean of 500 pounds, and a standard deviation of 50. Standard deviation of 50. We didn't talk at all about signs, about variables. This x that I used right here, x bar, this is called the sample. This is called a sample mean, and this is called the standard deviation. This lowercase sigma is standard deviation. All right. Now if we go back here, you'll see in our, oh nope, that's the wrong one. Every once in a while they'll use mu to represent the mean, but the mu is the population mean. So if you see mu, just remember they're talking about mean just like x bar. All right, but going back to our problem, the standard deviation is 50. So we wrote that down. The weight of adult female grizzly bears is approximately normal distributed with a mean of 300. So let's do a mean of 300. So these are the females, and a standard deviation of about 40. So this is my females. These are my males. Approximately, what would the weight of a female grizzly bear with the same standardized score, or z-score, as a male grizzly bear with a weight of 530 pounds? All right, so in other words, my value that they just gave us is 530 pounds. So my value that they're giving us is 530. And they do this often. They want to compare two groups. So we're going to find out z-score just by using our formula, which is 530 minus our mean, which is 500, divided by the standard deviation, which is 50. So my z-score turns out to be 0.6. And when we compare that to our females, we don't know what the value is. That's what they're asking us. They're asking us to find the value. So we don't know what our value is. That's going to be equivalent to our males. So we're going to do the same thing, but this time we're going to say my z-score is 0.6, and my value minus my mean divided by my standard deviation. You're just going to do some cross multiplying here. So 40 times 0.6 is 24 equals V minus 300. You're going to add 300 to both sides, and V is equal to 324 pounds. So that means a female of 324 pounds is equivalent to a male of 530 pounds in that same percentage. All right, so the beautiful thing about that is this time they told us the z-score, they were looking for that. If they don't, just remember, if they give you a value and they tell you to compare it to something else, you're using z-scores. Exercise 4. Now, this is where we come into our spread. So the lifespan of a 60-watt light bulb produced by a company is normally distributed with a mean of 1450. So normally distributed, that's important. Mean of 1450 and a standard deviation of 8.5. If a 60-watt light bulb produced by the company is selected at random, what is the probability? So when they're asking for probability and then they give us a span, all right, it kind of tells us that we are going to be using norm CDF. Now, sometimes instead of giving us a span, they'll say last at least 1400 hours. So if they say at least, that means it's going to be from 1400 to a very large number. So you can put like a million in there. If they say at most 1400, then you're going to start with a number like 0 and you're going to go to 1400. So sometimes the span is not obvious, but if it's using words at least or at most, your span is going to be exactly what we talked about. That 1400 will either be a minimum or it will be a maximum. All right, now let me show you how to do this on your calculator, and then you can practice this when you come into class. But before we get there, let's think about the numbers that we need. We need to know our span. Our span was 1440 to 1465. We also need our standard deviation, and we need, standard deviation is over here and our mean over here. All right, so those are the 4 things that we need to be able to put into our calculator. So from our regular calculator, we're going to go to menu, we're going to go to statistics, we're going to go to distributions. So 6, 5, norm CDF is 2. And if you see, it gives me a lower bound. So my lower bound is going to be 1440. My upper bound is going to be 1465. See where it says mu this time, but that's going to be our mean, which is our 1450. And our standard deviation is going to be 8.5. So when I hit OK, it gives me my probability. Bam, so nice. All right, so 0.84149. So then we just go to back to our sheet, and we see that our proper answer is number 3. Very cool, right? So again, what words are we looking for here? We're looking for the word probability. Of course, normally distributed is something that we're always looking. So normally distributed, probability, and a span that they give us, a spread. Okay, and they have to give you those 2 pieces of information, your mean and your standard deviation. Exercise 5. All right, so here we're going to talk about some words, and they have some serious questions on these words. And the beautiful thing is it's just vocabulary. So statistics vocabulary, bias. Now, bias doesn't always mean the same thing that we think it means in our everyday language, but basically it means that one outcome or a portion of the population is unfairly favored. All right, like so when I say I think my daughter is the most beautiful girl in the world, I'm being a little bit biased because I'm her mother. So if we wanted to know if she was the most beautiful girl in the world, we would have to ask people that did not have a relationship with her or know her. All right. Um, so something that's biased might be a survey. If you wanted to have a survey of um, all the people who, I don't know, drive in Poughkeepsie, you want to know how the roads are. You're finding the roads need help. Do they need help, being repaired after the winter? And what do? You ask people on Main Street. Well, maybe people on Main Street walk to the stores, and maybe, or you ask people at a bus stop and think, well, they don't really drive on the roads. They're not paying attention to the roads. They're not trying to swerve to avoid potholes. So you have to be very careful, and that's how they ask questions about bias, about what is a good sample. All right? So, an ideal unbiased study is to have a random sample. Okay, so a random sample is basically you're picking every fifth person walking into a drugstore, walking into a supermarket, places where people go generally, that everybody goes. So whether you're rich or poor or tall or short or educated or uneducated, everybody goes to the grocery store. So that's always a good place to get a random sample. So a census is a survey or poll of everyone in the population. All right, so every couple of years they try to do a census in the United States that gets information about how many kids they have, what the age of their kids are. But in a perfect world we get everybody, but that's almost impossible. An observational study, the most important thing, treatments are not imposed on subjects. So this means that you're not giving somebody a pill, you're not letting them use a certain kind of mouthwash, all right? And no causation can be established here. That is the most important part of this, all right? So, highlighter. This is the most important part. No causation can be established. And a controlled experiment has a control group and a treatment group. All right, so causation can be concluded here. So what that's saying is, in a controlled experiment, usually you have two groups. One gets the product, one doesn't. So a lot of drug companies do this. They give one group what's called a placebo. So they're taking a pill every day, but it's really not doing anything. It doesn't have that active ingredient in it. And then they give the other group, because sometimes we think in our heads, oh, I feel better. I took a pill this morning. So, all of a sudden, like, you think I took an Advil, my knee feels better. But what if we gave you an Advil that really wasn't an Advil and just was like what they call a sugar pill and just had absolutely no effect in it whatsoever? But sometimes the brain likes to play tricks on you. So that's what a lot of times, different drug companies will use, or household companies. Like you might use different types of mouthwash, like I explained before. This mouthwash is supposed to make your mouth minty fresh all day long, and then this one isn't. So you might try giving somebody one with that minty fresh all day feeling and one just a regular mouthwash, and see how they compare to each other. Okay, I'm talking too much. Exercise 5. Which statement about statistical study is true? A survey of all English classes in a high school would be a good sample to determine the number of hours throughout the school spend studying. Number of hours students throughout the school spend studying. Okay, I forgot the word students. All right, does that sound good? I think that sounds okay. Everybody takes English. It's kind of like the supermarket, right? So 2 says a survey of all ninth graders in a high school would be a good sample to determine the number of student parking spaces we need in the high school. Well, most ninth graders are 14 or 15 years old, and most of them aren't driving yet. So I don't think that's going to be a good example, or a good sample to use. I did use sample. Okay. So 3, a survey of all students in one lunch period in the high school would be a good sample to determine the number of hours adults spend on social media websites. No, because high school students aren't necessarily considered adults. So, and obviously you guys can understand that adults don't use the same social media websites that the kids use. So, 4, A survey of all calculus students in the high school would be a good sample to determine the number of students throughout the school who didn't like math, who don't like math. Well, if you're taking calculus, you've been pretty successful in math. I'm not saying that you like it or you don't like it, but you most definitely don't hate it because you're still been taking math for every year that you've been in school. So I don't think that's a good example. So here I would say 1 is my statistical study that makes sense to me. Okay, looking on to exercise 6. A doctor wants to test the effectiveness of a new drug on her patients. She separates her sample of patients into 2 groups and administers the drug to only these groups. She then compares the results. Which type of study best describes this situation? Well, we just talked about this. This is a controlled experiment. It's a very good example of a controlled experiment. All right? So, in other words, it's not going to be a census. We're not surveying people. We're not surveying people. We're not observing, and we are, well, even though we are observing, this is called a controlled experiment. So when you get a question like this, have a 10-second dance party because that's as easy as it gets. All right, so that's the end of 12.1. And I might be putting the solutions to 12.1 on Google Classroom and on the Drive so you have them. Okay, I'm not going to do a video on them, but I'm definitely going to upload the solutions to them because I think that it will help you when you are doing your problems. Okay, so see you next time. Make good choices always.